If I ever need to rotate an axis by a particular angle, I can use these formulas. X is equal to x prime cosine theta minus y prime sine theta. Y is equal to x prime sine theta plus y prime cosine theta. And all I do is I take these two equations and then I substitute them into my regular formula. So if I had x squared plus y, x plus 3, I would just substitute these in, and then for whatever angle I want to rotate it, then I would simply solve it for cosine of whatever that angle would be, and then I substitute them in. So I substitute the x's in here, substitute the y's in here. So that's simple enough. Also, why this section appears in this order is because it's often used in these books for conics, because if a conic is rotated like this one here, this is a hyperbola rotated at 45 degrees, and in fact the equation is xy is equal to 1. It could be any number, but it's more familiar as this. Now if I were to look at this, I wouldn't immediately think that it would be a conic, but it actually is. It's a hyperbola rotated 45 degrees. So if I wanted to express this in the form of a hyperbola, what I can do is just rotate my point of view 45 degrees. So this would be my y-axis, and then my x-axis would stretch over this way. So that's what the point of it is. And that's where the second formula comes into play, because if I'm not given an angle, how do I know how far to rotate something in order to get me something that's easy to work with as far as conics are concerned? Well, I use this formula, cotangent of 2 theta is equal to a minus c over b. And basically what this formula does is it looks for the situation where b is 0. And if b is 0, then I'm going to be left with a conic. I'm going to have an x squared, a y squared, those are going to be positive or negative, or I'm just going to have an x or a y squared, in which case it would be a parabola pointing one way or the other.